Hey there, everybody. What we're going to talk about today is index notation. Index notation is something that you've seen many, many times. You probably just don't realize you've seen it. What index notation is when you have something that's written like this, 2 to the power of 5. That's also considered index notation, 2 to the index of 5. And how we look at this is, as you probably know, the 2 is considered the base, and the 5 is considered the index, or we also call it the power, or we also call it the exponent. All of these things are correct. All of these things mean the same exact thing, the index notation. So what we're going to do is we're going to walk through about 5 or 6 different properties, and we're going to kind of summarize our properties for index notation. It's a little bit of review for a lot of you, might be some new stuff for a few of you. So let's see. Let's start with, I'm going to use general variables to come up with a general example, and then I'll give you a specific example to kind of see how it works. So the first one is a to the m times a to the n. And what does this equal? Well, you may already have it in your head what that equals, but let's take a look. So a to the m, let's look at specific examples. I'm going to say a to the third times a squared. So that means we've got two different exponents, just like we do in our red example, m and n. Here the m and n is 3 and 2. So this means you've got a times a times a times a times a. So these 3 come from here, and these 2 come from here. So we've got a to the third, or this is the same thing as a to the third, and this thing is the same thing as a squared. So what do we end up with? How many a's do we end up in total? Well, we've got 1, 2, 3, 4, 5, so we've got a to the 5th power. All right, well, how did we get that a to the 5th power? Well, a shortcut way that we could say that we did that is we just added up our 2 exponents. So, shortcut way, a to the m times a to the n is the same thing as a to the m plus n. Yeah, all right. So, similar to that, we're going to look at a to the m over a to the n. So now we've got a fraction for these two things. Again, it's going to work a very similar way. Let's use the third and second power again. So a cubed over a squared. All right, well, we'll break this out a little bit. We've got a times a times a over a times a. So what do we do with these? Well, when we've got fractions, we've got all multiplications, and we're trying to simplify this, we'll cancel out those, and we're left with a to the 1st power. All right, how could we do this mathematically? Well, if we look at that, again, looking at the indexes, the exponents, we could say, well, 1 is equal to 3 minus 2. So that's going to give us a to the 1st power. So we can come up with a generalization over here. In the red, we can say, well, a to the m over a to the n is the same thing as a to the m minus n. So we're just subtracting our exponents. All right, here's another one. A to the m to the nth power. Okay, so now we've got a power of a power. All right, so power of a power. So that means if we've got a cubed squared, so a to the m to the n power. All right, let's break this out. So that's going to say a cubed times a cubed. Well, up here in our first rule, up in this one, we said that, well, if we're multiplying the same bases, we can add together the exponents. So that's going to be the same thing as a to the 3 plus 3, which is a to the 6th power. Well, you might notice also that if we go from here to here, you could also say, well, to get to 6 using those exponents, I could multiply them. So I could take a to the 3rd. Oh, let's fix that. Let's get that out of there. Whoopsies. There we go. get that so it's a little bit lower. So we can say a to the third times a to the second. It's still kind of in the line, sorry about that. So you're just multiplying those two things together to get a to the 6th power. So here we can summarize this as a to the n power. So we're just multiplying those two things together. All right, let's get a little bit more space in here so that way we can make sure that we get everything to fit. Kind of, oh, hello. Let's get rid of that. I don't know what that's from, but we'll get rid of that. And all right, so back to it. So we've got 2 more, and then I'm going to go into a very large example for you. So the next one, a b to the nth power. Okay, so now we've got 2 different bases in here. 2 different bases. So that would be, let's take a look at this. That would be ab to the 3rd power. All right, ab to the 3rd power is the same thing as a times b times a times b times a times b. All right, well, we can rearrange this. We know that that's one big string of multiplication. We can rearrange it and say a times a times a times b times b times b, which is a cubed b cubed. So what do we get when we went from our beginning to our end over here? We basically just distributed that exponent across our 2 bases. So when you are multiplying 2 different bases, you can distribute the exponent. We're going to talk about some differences when we're adding or subtracting those bases and we've got it to a power. What do we do then? We'll talk about that in another video though. All right, one more like this and then I'm going to go into a really big example for you. So we've got a over b to the nth power. Well, you can probably figure out where we're going to go with this one just from looking at the stuff up above. But if we have a over b and we're going to take that cubed, we're going to say a over b times a over b times a over b. All right? So a times a in the numerator, b times b times b in the denominator, so we end up with a cubed over b cubed. And we get a very similar thing as we did with when we're multiplying. So when we multiply or we divide, then we just distribute, oh, not to the 3rd power, that's going to be to the m power, a to the m power over b to the m power. Okay, so these are 1, 2, 3, 4, 5 of your major properties. 5 of your major properties. 1, 2, 3, 4, 5. Now, we're going to talk about 2 more real quick. But to do that, I'm going to show you kind of an example, and then we're going to build into what our general rules are. So let me get this out of the way first, because we're going to need a lot of space for this. All right. So I want to look at the powers of 10. I'm going to just look at the powers of 10. So I'm going to start at 10 to the 1st power. We all know what 10 to the 1st power is. 10 to the 1st power is 10. All right, so if I go 10 to the 2nd power, well, we know what that is too. That's going to be 10 times 10. As we're going up, we're multiplying by 10. So we go up and we get a result of 100, right? Right. So that's going to be 100. Here, we'll just put this 10 down here just to keep it consistent. So we're multiplying by 10. If we go 10 to the cube, 10 cubed, we know that's going to be 10 times 10 times 10. So again, as we move up, we're multiplying by 10, and our result is going to be 1,000. All pretty basic stuff, stuff you've done before, stuff you've seen before. But let's look at it going the other direction. What happens as we go down? So if we go down here, we're dividing by 10, right? 1,000 divided by 10 is 100. If we go down one more, 100 divided, and we're going to divide that by 10. So over here on the left, we're multiplying by 10. As we're going down, we're dividing by 10. So 100 divided by 10 is 10. So what is it going to be if we divide by 10 again? Well, 10 divided by 10 is 1. Yeah, 1. So, and then if we follow this pattern, over here we started at 10 to the third power, and then we had 10 to the second power, and then we had 10 to the first power. So as we go down one more, we're going to go 10 to the 0 power. 10 to the 0 power is 1. Okay, awesome. Now, let's take it one more step. What happens if we go down one more? Well, we're still going to divide by 10. We're still going to follow that same exact pattern. And what is 1 divided by 10? Well, that's 1 over 10. All right, but what about over here on the left? What power is that now? Well, if we follow our same pattern, if we keep on going down by one integer, then it's going to be 10 to the negative 1 power. We can also write that as 0.1. All right, one more just to kind of get the point across here. What if we divided this by 10 again? What are we going to get? All right, well, not always good with fractions, so let's do a little scratch work over here. 1 over 10 divided by 10, well, that's going to be the same as 1 over 10 times 1 over 10, which is 1 over 100. 1 over 100, awesome. So 1 over 100, what's another way to write 100 that we did up above? Well, 100 is the same thing as 1 over 10 squared. So if we follow our exponent pattern here, we've got 10 to the negative 2 power, which as a decimal, we'll just write like that. But you can also see, oh, it's kind of off here, that you can see that 10 to the negative 2 power is the same as 1 over 10 to the 2 power. So here we come up with two new summaries, two new things that you may not have known before. So if we have, I'm going to talk in general terms now, a to the negative n power, a to the negative n power. So just like over here down at the bottom, we can see that it becomes 1 over a to the positive n power. So it just means you put it in the denominator. And the last thing that we probably discovered here that you may or may not have known is to the 0 power. Anything to the 0 power is always going to be 1. So that's the summary of the beginning of all of our index rules, and hopefully it's mostly a review and nothing too new, and it's going to be kind of easy for you. So good luck, and I'll see you or talk to you in the next video. Bye bye.